This video is about the road Mirage. Note the two orange signs ahead. The car is maintaining a fairly constant speed of about 30 meters per second. The mirage of an orange sign on the left will be shortly visible. There it is. It appears that the orange is reflected from the road off a layer of water. We are going to note when the mirage of the orange sign vanishes. Now, every second we travel 30 meters. We are getting close to the sign, almost there. And as we pass the sign, we will note the distance, 480 meters. We will need the dimensions of the sign for our analysis. The low soft shoulder sign has the standard dimension of 3 feet for each side, that is 0.91 meter. Therefore, the vertical diagonal is 1.3 meters. By measuring the pixel lengths with a software graphics program and using length ratios, we arrive at 1.8 meters for the length of the support for the sign. Next, we will need the height from the ground of the observer in the car. When I took the video of the Mirage, I had my smartphone at about this height from the ground. Getting to 2 meter stick, 120 centimeters, 1.2 meters. Though refraction is the cause of the mirage, we will approximate the mirage as occurring from one single reflection from the road surface. We pick the lower part of the sign as the last rays from the orange sign reaching the eye. Taking the ratio of 1.8 meters to the sum of 1.2 plus 1.8, we arrive at the 288 meters from the sign to the point of reflection. The angle alpha is the mirage angle. The tangent of alpha is 1.8 over 288. When you use a calculator to obtain the arctangent, you find that the alpha angle equals 0.36 degrees, a very, very small angle. Introducing refraction, the light bends away from the normal as it enters a medium with less index of refraction. The index of refraction of air reduces as the air gets warmer. Note that n times sine of theta is a constant. For the mirage, we have a gradient in the index of refraction. We have a cold temperature at the observer, the temperature from the weather station, and a hot temperature at the road surface, which value we find from engineers who study asphalt surface temperatures given the ambient weather temperature. Then the refractive index of air can be calculated in each case based on the temperature. Plugging in the values, you can solve for the angle theta and then find its complementary angle alpha. The calculated value is essentially the same as that found earlier. I would like to thank my dad for telling me about mirages when I was a boy on a family trip to Beaufort, North Carolina in 1961. Returning 58 years later, I shot the Mirage video. Also thanks to John Rideout, transportation coordinator at my school, for discussions on highway lane widths and signs. Finally, thanks to my lovely wife Margaret for driving the car for the video.